Hi, in this video we're going to talk about classifying triangles. Before we get into it, if at any point you find something that's useful, go ahead and click the like button. That let me know that this video was helpful to you in some way. And if you haven't already, go ahead and subscribe. And yeah, let's get started. So classifying a triangle is really a way of putting a triangle in a class. Now we can do that two different ways. We can classify a triangle based on its sides and based on its angles. If we know the side measurements of a triangle, we can call it either an equilateral triangle, an isosceles, or a scalene. Now these are just variations of these types of triangles. What we're going to talk about here is the definition, maybe the symbol representation of these different triangles, and then we'll do a few examples where I show you how to classify a triangle based on the information provided. So let's get to it here. An equilateral triangle means, and if you look at the word here, equilateral, right? We have the word equal here. Lateral means sides, or in Spanish, if you know Spanish, is lado. Equilateral, equal lados, right? Those are same sides. So if a triangle has three sides that are the same, if all three sides measure the same length, we call this an equilateral triangle. Isosceles, on the other hand, is only two sides have to be the same. And if you want to look at this triangle a little bit sideways, if two sides are the same, say this one and this one, then it's considered an isosceles triangle. And then finally we have a scalene. Scalene triangles are the ones that have nothing in common. So I will not be able to put a tick mark on any one of these because none of these would be the same length. They all measure something different. Okay? So we got equilateral, all three sides are the same. Isosceles, two sides are the same. And scalene, none of the sides are the same. Now, if a triangle has angle measurements, like degrees and stuff, we can use the degree measurements to define the classification of a triangle. For example, if all three angles are acute, right? Say we have three angles here. If each one of these angles is less than 90 degrees, we can say that it's an acute triangle. All three angles must be less than 90 for that to be true. As we move over to the right triangle, if it has one right angle or a 90-degree angle, if 1 degree equals 90 degrees or one of the corners is 90 degrees, then we consider this to be a right triangle. We will spend a lot of time talking about specific right triangles and properties later during the year. Now finally, an obtuse is if one of the angles is greater than 90 degrees. So if this angle, for example, is an obtuse angle greater than 90, right? So anywhere between 90.1 to 179, right? Something less than 180 and greater than 90, we would have an obtuse triangle. So ideally, we would have both things, right? The angle measurement and the side measurement. But based on the information that we have or are given, we can classify the triangle based on that quality. So let's try a few. Here we have two scenarios. We're going to want to classify this triangle. Let's start with the one on the left. So here I have these two side measurements are the same, right? AC is 3 and AB is 3. So those two are congruent. The bottom one is different. So because the two sides are the same, I already know this is going to be an isosceles triangle. Now, because the angles are given as well, I could be more specific. Notice how one of these angles is 90 degrees. That means that this is a right triangle. If you combine these two words, we have a right isosceles triangle as its most specific classification. Let's look at this other example. Over here we have, if we look at the sides, we are given three side measurements that are different. We have 3, 5, and 7. None of the sides measure the same length. So I already know that this is going to be a scalene triangle. Now, based on the angles, I do notice that one of the angles is obtuse. Therefore, this is going to be an obtuse triangle. Or together, obtuse scalene triangle. Right? As I said, ideally we would know both sets of information. Sometimes you just know the angles, sometimes you just know the sides. If you know both, even better. You can give it like a first and last name. And I would always start with the angle measure, followed by the side measure. And that's going to be the name of the triangle. So right isosceles or obtuse scalene triangle. So let's try a couple more. Feel free to pause this, give it your try yourself, and see if you can label it yourself. Let's start with triangle ABD here at the top. ABD. So triangle ABD has to include these three vertices. So I'm going to color this blue. I'm focused on ABD. That's what I'm focused on right now. Okay, I'm going to highlight it. It'll probably be easier to highlight. ABD. Focused on those three vertices or these corners. I don't know any information about the sides. I just know the angles. And since all three angles are less than 90, this is going to be considered an acute triangle. Now, this particular triangle has an alternative name. Because all of them have the same angle and they're all acute, we actually want to call this equiangular. Equiangular triangle, which means equal angles triangle, right? These two names are interchangeable. Acute just means all the angles are less than 90. Equiangular is when all three angles are equivalent. Kind of like equilateral, equal sides, this one would be equal angles, okay? And that's a very particular type of acute triangle. Let's look at triangle BDC. I'll do this one in red. BDC starts here, goes to D and C. This one has two acute angles, but one of them is obtuse. So since we have 120 degrees here, we're going to call this an obtuse triangle. As long as one of the angles is greater than 90, we have automatically an obtuse triangle. And finally, triangle ABC. I'll do this one in green. ABC will encompass everything. A, B, C. This is the biggest triangle possible. For this one, I want to pay particular attention to angle B, because angle B is composed of two smaller angles. If I add these two angles together, 60 plus 30 means I have 90 degrees. So this corner here at B is a 90-degree angle. Therefore, this green triangle, ABC, is considered a right triangle. Okay? All right. So classifying it based on its sides, based on its angles. Let's try another example where we now use these names or these qualifications to solve an actual problem. So far we've been naming the triangles by classifying them. Here's an example of where we step things up. Okay, we have a triangle, LMN, as an isosceles triangle, where LM equals LN. LM is given as 3x minus 2, LN is 2x plus 1, and MN equals 5x minus 2. Find the value of x. So here, we want to take what we learned and what we know to be able to set up a problem and solve it. I'm definitely a visual person, so I have to see the picture. So I'm going to draw it. I'm going to draw a triangle named LMN. That's isosceles. So I need to be able to draw that first. Isosceles means that two sides are congruent. So I'm going to draw this picture so that two sides are roughly the same length. This one and this one. It's too long. Anyway. Now, LMN, right? I'm going to call this LMN. And I'm going to label it. I know LM equals LN, which is why I put LM and LN a tick mark on both, because those two are congruent. Now, LM is classified or named as 3x minus 2. ln can be represented with 2x plus 1. And mn as 5x minus 2. Now that I've labeled my picture, now I want to be able to find the value of x. I want to solve for x. To do that, I want to write an equation. Now, I do notice two things from this triangle. I notice that because it's an isosceles triangle, this length equals this length. They're congruent, right? If they're equal, I can actually make that the equation. I can simply say 3x minus 2 equals 2x plus 1. I use the information that I was provided to solve this equation. Once I set it up, combine like terms, move everything to one side, isolate the variable, things like that. So let's move the x to the left. I'm going to subtract 2x on both sides. I have 3x minus 2x is just 1x equals 1. To get rid of the 2, we do the opposite. We add 2 to both sides. And I have x equals 3. I found the value of x. And there it is. First, I draw my picture based on the information that I know, isosceles. I identify what two things are going to be the same because of the definition. Okay? And then I set up the two things that are actually equal, and I solve. Notice how we didn't even need the length of ln. It wasn't necessary to find the value of x. All right, guys, I hope this has helped. If at any point you learned something or you felt like something was very easy to understand or helped you, please click the like button. It lets me know that it was useful to you. If you have any questions, please comment below. And of course, subscribe if you haven't already. All right, everyone. We'll calculator.